Hey all, so today we are going to talk about dimension of a physical quantity. So let us start with it. So nature of a physical quantity is described by its dimension. So what does it mean? It means that all the physical quantities which are represented by derived units can be expressed in terms of some combination of fundamental quantities. So let us take an example to understand it. Like force is a derived quantity, so it can be written as mass multiplied by the acceleration. Now what is mass? Mass is a fundamental quantity, and acceleration, which is again a derived quantity, can be written as length divided by time square. Now what does it mean? It means that the base quantities can act as a dimension of physical world. So dimension of physical quantity is represented by a square bracket. Now let us find out the dimension of the fundamental quantities. So dimensions of fundamental quantities. So what are the dimensions of what are the different fundamental quantities? The first is length. So length has a dimension in a square bracket capital L. Now similarly, then we have time, which is another fundamental quantity, which is represented by dimension, square bracket T. Now then we have mass, represented by square bracket M. Then we have thermodynamical temperature. So thermodynamical temperature can be written as thermodynamical temperature is represented by the square bracket capital theta. And then we have electric current, represented by capital A. Then we have other quantity, what we call as the luminous intensity. Represented by a small CD, that is candela, and then we have amount of substance, which is represented by mole, MOL in square bracket. So dimension of any physical quantity is written in the powers of dimensions of fundamental units. So let us take a simple example to understand it. So force, which is represented by mass multiplied by the acceleration, and or mass multiplied by length divided by time square, where length is represented by capital L, as we stated earlier, and time is represented by capital T, and mass as capital M. So using the standard dimension of fundamental units, we can find the dimension of force as ml t to the power minus 2, where m is the dimension of mass, L is the dimension of length, and t is the dimension of time. So it means that force depends on the first power of mass, first power of length, and minus 2 power of the time. Expression which shows how and which of the base quantities represent the dimension of a physical quantity is called the dimensional formula of the given physical quantity. So let us take a simple example to understand it. So velocity, which is represented by displacement and divided by the time taken, is displacement is nothing but the length of the path traversed divided by a capital L, so it has dimension as capital L and the time taken as the capital T. So dimensional formula of velocity will be L t to the power minus 1. An equation obtained by equating a physical quantity with its dimensional formula is called the dimensional equation of the physical quantity. Let us take simple example to understand it. Like volume, which is represented by capital V, has a dimensional formula as m to the power 0 L cube t to the power 0. Similarly, velocity, which is represented by small v, has a dimensional formula m to the power 0 L t to the power minus 1. So let us calculate the dimensional formula of some of the physical quantities. So we will start from the velocity. So velocity has the formula is displacement divided by the time taken. So displacement is nothing but the length of the path, and then which has a dimension L, and then dimension of time taken is t. Then the dimension of velocity will be, or dimensional formula of the velocity will be L t to the power minus 1. Now let us go to some other physical quantity like acceleration. So acceleration is defined by velocity, or basically change in velocity. Change in velocity divided by time taken. So what is the change in velocity? So it is nothing but, so change in velocity has also the dimension as v, which is as defined as earlier is L t to the power minus 1 divided by the dimension of time t. So it means that acceleration has a dimension of L t to the power minus 2. Now let us go to another physical quantity, that is force. So force is defined as mass of the physical quantity multiplied by the acceleration. So what is the mass? Mass is represented by capital M, and then acceleration is represented by L t to the power minus 2. So it means that the force has a dimensional formula of m L t to the power minus 2. Now let us another physical quantity, the work done. So work done is defined as force multiplied by the displacement. Right? So it is nothing but the force at the dimension of m L t to the power minus 2, which we derived earlier. Then dimension of displacement is L. So dimension of work done is nothing but m L square t to the power minus 2. Now let us go to another physical quantity, which is energy. So let us go to the kinetic energy. So kinetic energy is defined as half m v square. So it has a dimension of mass and v, which is L t to the power minus 1 square. It means that it can be written as m L square t to the power minus 2, which is same as the work done. Now let us go to the another physical quantity, which is potential energy, which is equals to mgh. mgh for mechanical system, then which can be written as mass into g. G is nothing but L, acceleration due to gravity, it has Lt to the power minus 2, and then H is nothing but L. So it gives you m L square T to the power minus 2. Please note it down.